the lines. In each of the following problems, locate the line in the view in which it is missing. Show all of your construction lines neatly as possible, label all points. So we're projecting into the missing view. I did add one thing. I would like you to label all true length lines, so you recognize when they occur. So first, let's go and do the projection. Okay, so I'm going to label my points. So I know there's point 1, there's 1, here's 2, here's 2. I'm going to get it in the top view, so I know I can project perpendicular. So I know point 2 has to fall on that line. Point 1 has to fall on that line. Where do they fall? Well, I'm going to go to my related view, and I'm going to measure the distance from viewing plane to 2, viewing plane to 2. Make sure you stay on the correct lines for the points. Okay. So there's 2. Now 1, you're going to find when you measure this guy is the same distance. So it's here. Where there's point 2, there's point 1. There's my line. Okay, so we now projected the line. Any questions on that portion? Next thing we're going to do is look at it and say, are any of these lines true length? Do we have a true length line on here? Yeah, we do. Which one is it? Elise?
It's 1, 2 inside.
Well, what we're looking at, is this true length, is that true length, or is that true length?
The middle. It's the middle.
Which is what view? It's the front view.
Yes.
Okay, let's use that terminology. So our front view, yeah, that line's true length. How do you know it's true length? Well, this line's now parallel to here, must appear true length. This one's parallel, must appear true length. So in this case, yes, I do have one. So I would come in and label that TL.
You actually knew that before you drew the upper one.
Yep, you did. Okay. So you're doing that on all of these. Let's go to the next page. The instructions. Find the true length of the line shown, label it true length, and write its length to the nearest 0.05 inches. So some of these you're going to do some work, some of them you aren't. On the first one, do you have a true length line? Okay. No projection needed. Measure it and label it. That's it. Come to number 2. Do you have a true length line here? Yes, you do. No projection needed. Locate the true length line, label it, and measure. Let's go to 4. Do we have a true length line in number 4? No, we don't. Okay. How do you know that there is no true length in here? Well, none of them are parallel to the fold line, so all of them are foreshortened. So we need to now project for a true length line. How am I going to do that? I'm going to pick any one of these lines. In this one, I got more room to work in the top, so I'm going to pick this top one. And let's go ahead and project that true length line. What I'm going to do is come in here and get parallel to that line. I'm going to draw my fold line. Okay. And I just want to make sure that is parallel to that line. Once I have that, I can now project perpendicular to that, and I don't know that I'm exactly perpendicular up here. So I can project perpendicular where this angle is 90 degrees. Now, one thing that might help you here is you might want to label your points. 1, 2, 2, 1, 1, 2. Now, I know point 1 has to fall on this line. I know point 2 has to fall on here. How am I going to find out where they fall? Anybody know? How, Amy?
You measure that line, the front view line to the top of the box, and then you'd measure the same way from that perpendicular line to the top, right?
You betcha. That's it right on the nose. I'm gonna measure from fold line to point on one. It's gonna be the same distance, fold line to one. Okay. Then I'm gonna come measure fold line to two, fold line to two. Okay. So let's do that. So I'm gonna take this measurement, and again, you might want to throw yourself some guidelines out. The more you put, the more accurate you'll be, because you want that straight line distance. You don't want to be measuring an angle. Okay. So I'm going to put that up. That goes to there. And then 2 is to here. Now I know what I need to know. So there's 2 and 1. So 1, 2. That guy's true length. I can now measure it and put it in the answer. One other caveat. Do you have a check that you can do in this type of situation to make sure you projected it right? You do.
Oh, you could draw that.
If it's true length, all other views of the line are foreshortened, right?
Yeah.
So if you draw a true length line and you measure it, and then you go back to those other 3 and you find another line in there that's longer than what you just projected for your true length, you screwed up somewhere. Because that true length has to be the longest projected part of the line, right? It can't ever be bigger. It's always true size or foreshortened. Okay. So you do have a check. All right, do you understand what to do on this worksheet now? Okay. Let's go to sheet 4. Now we've progressed from points to lines, now from lines to planes. First step, recognize the plane. What type of plane are we doing? Inclined, Andy? Yeah. Edge view in one view, foreshortened in the other 2 views. Okay. So this is an incline. So we're at law 2. All you're going to do is put a line right here. Should we do this one? Please. So you want to now, you want to go to your edge view. Because remember, that's the whole point of doing laws 1 and 2 is to get to edge. With an incline, you don't have to do them though, because you have an edge. First thing I would do is label your points. There's 1, 2, 3. That's going to be 1 here. 2 is going to be somewhere about right here. 3 here. 1, 2, 3. I'm then going to draw a viewing plane parallel to my edge view because law 3 states the plane must appear true size and shape in the viewing plane parallel to its edge view. Again, I'll draw that viewing plane. I need to find where 2 is. So I'm kind of trying to keep straight here. I think 2 is right there. Now I'm then going to project perpendicular. I know 3 has to be on that one, 2 on that one, 1 on that one. We kind of back away so you can see what I'm doing here. So we're applying law 3.
And you found 2 just because it's straight down and straight over.
Yes, you can find 2 just by setting a triangle up and keeping square on this stuff. 2 if you project it straight over, it's going to get here. Again, this is a case where, I'll wait for a second, let people quit scribbling so I got your attention. Are any of my lines in my two foreshortened views of the incline, are any of them true size? Just ask yourself, is line 1, 3 parallel to this?
No.
No. Okay, so therefore it's not true length over here. 1, 2 parallel? Nope. 2, 3? Nope. So this is all foreshortened. Okay, and that's all you really need to do. This is why I say, we don't care if we see true length on here, all we need is edge view. We've got to have the edge, but we don't care if we're looking at it in this instance where you would see a side true length, or in this instance where you wouldn't. We don't really care. We're still going to get true size. We got edge view. All right, so at this point now, I can come to either view. I don't have to do just one, but I need two views, right? I projected from one back. I'm going to go to this view or this view. They should equal. So I just grab the distance from one. Fold line to point 1. Fold line to point 1. So there's 1. Then I do fold line to 2. Fold line to 2. And then fold line to 3. Fold line to 3. So here is 3, 2, 1, and we connect our dots. There's the plane, true size and shape. Okay, any questions on that? Let's go to the last worksheet then. Haven't seen one of these yet. What type of plane are we dealing with? What's that game? Yep. Foreshortened in all views. So we got an oblique plane. First thing you want to do when you're dealing with obliques, you've got to do laws 1, 2, and 3. Is law 1 satisfied anywhere here? Okay, just look at it. Parallel, parallel, parallel? No. So everything here is foreshortened. None of this is parallel to that or that. Everything here is foreshortened, everything here is foreshortened. No true length line. You're going to do 3 rotations here, folks. So the first thing you got to do, and I'm not going to do these, I'll let you figure them out. I just grab one of these, and let's say we come in right here. So maybe we ought to label these. 1, 1, 1, 2, 2, 2, 3, 3, 3. So I'm going to just draw one. I can come here. I could actually come up and come off of that one where I'm doing line 1, 2 over here. It doesn't matter. You get the same result. Let's say I'm doing this one, so I'm going to apply law 1 here. So in essence, I'm going to project, and then find all those measurements. I'll just kind of estimate 3, 1's out there a little bit, 2's a little closer. So I'm going to be something like this. Use a different color. Now, what's important about this rotation? Why did we do it? Law 1. A line must appear true length in the viewing plane parallel to it. A line must appear true length in the viewing plane. We did it for the whole thing to get true length, right? So I now know, here's point 1, here's point 2, there's my true length line. That's why I did that. Because now I can apply law 2. I know my true length line. I can come in and put my perpendicular bisector and do law number 2 here. That gives me the angle. What should I get up here? I'd better get an edge. Where that's 1, 2, that will be 3. What's important about that view? I have edge view. Now I know how to do law 3. Right? Where I project it through.
So to do the projection into law 2, you could use any of the lines, they're all true.
No, they aren't.
Only-
You're talking here, right?
Mhm.
On the law 1? No, I only got one true length line. It's line 1, 2.
That's why just a point on the line above.
Because you would have had to draw a parallel line to 2 and 3, or 1 and 3, to make those true length. Right?
No, I'm just carrying this point with me. This is foreshortening. I'm not seeing that thing true size.
The draw line perpendicular to
You're, yeah, you're probably looking at this somehow kind of like this, or like this right now. But you're seeing this line right here is true length. Okay? That's the only thing. The rest of it's foreshortened. It's twisted somehow. That's why you want to kind of label your point so you know what you're dealing with, because this is the only true length line on it.
And that's
Because
you lined it up with
Yeah.
parallel.
That's correct. I drew this viewing plane, law 1. Line must appear true length in viewing plane parallel to it. So I drew parallel to this line 1, 2. So line 1, 2 needs to be true length over here. I don't care about line 1, 3 or 2, 3. I'm just bringing them with me, but they're going to be foreshortened. But they're part of the plane, so I got to project them. But there's nothing true size about it. It's not till I get to law 3 where everything is true size. Okay? So these are just setting it up because what it's trying to do here is to get this in a logical sense. Because, you know, if I've got an object like this that has an inclined plane on it, if I apply law 3 and I rotate, I get true size and shape, one view. But if you don't have that law and you say, well, I need true size, and so you just grab it and start rotating it, I mean, hey, you can draw this thing till the cows come home, and you're never going to get true size of that plane. That's why these laws are so kind of beautiful. They save us a ton of work, and they just work every single time. In a black and white world, like I try and live in, I love this, because I get the same answer every time. That's why we call it a law. All right, so apply that. If you have problems with it, get me involved. I like doing this stuff. Love it. As a matter of fact, I'd be more than happy to sit down and go over it with you. We will go over this as a class tomorrow. See how well you did. And then there's going to be another group of these that come along that may get a little harder, may get a little easier, depending on your thoughts. But we need to get a good grasp of this before we move to the next level. Yes?
So in the first part, we got the true length 1, 2.
Yep.
And then we did law 2, which gives us
the
what?
point.
Point view of law 1, 2.
Point view of, okay.
And then you draw
So we had this line somewhere like this. We don't know how it was. But I drew that viewing plane right there, so I'm looking right here, right, Cheryl? And so therefore, as I rotate to that, I get that true length, right? Then I drew a viewing plane perpendicular to it, and I rotated it, so I had point view. And since that line is part of a plane, I have to see the plane on edge. Then I rotated one more time, I drew a viewing plane parallel to it, snuck it up, I get the whole plane that way.
That part's the exact same thing as what we did on the page.
All right, let's just break for a couple of minutes. We've been going 55 minutes. I do have the last test I want to hand out. You're probably kind of itching to see if we finally got those all taken. I think everybody's all caught up on those. So we'll go over those. We'll take a quick